Hi, welcome back. This lab is about shear plate interferometers and optical testing with them. In this video, I'll do a brief review of what wedged and non-wedged shear plate interferometers are. I'll look at the experimental setup we used to test aberrations with them, and finally look at the results that we got. Recall, a shear plate is simply an interferometer that superimposes a wavefront with a shifted version of that same wavefront. This superposition allows us to see variations on the wavefront in the form of an interferogram. Hence, if the wavefront is flat with no variation, we should see a null fringe. A wedged shear plate is another type of shear plate that gives a little bit more information by imparting a tilt onto one of the wavefronts. One of the useful characteristics that comes from this is that you can now infer the direction of defocus. Because of the inherent tilt, a zero aberration test would result in linear fringes instead of a null fringe. The test setup for the non-wedged shear plate was very similar to previous labs with a Heaney laser, spatial filter, beam expander, a non-wedged shear plate, and the viewing screen. Starting out, there is some inherent aberration that could not be corrected out of the system. With this setup, the collimation lens was adjusted to observe the effects its position has on aberration in the system. Adding defocus to the collimation lens caused more fringes to appear that were relatively linear. Decenter did not cause a visibly larger amount of fringes to appear on the interferogram, but the viewing screen visibly passed through multiple fringes. And finally, the culmination of the two, adding defocus and decenter, can be seen on the video on the right. Pictures for each one of these situations mentioned earlier, as well as changing the collimation lens orientation from max spherical aberration, were all taken and analyzed. Seidel aberration coefficients were calculated to reconstruct the interferogram shown below. The reconstructed image and the image taken in the lab are all fairly similar, except the lab image is slightly cut off on the right. The calculated Seidel aberrations are seen in this table. Note that every time defocus was added, that was clearly demonstrated in the Seidel coefficient for defocus, and there was an obvious increase in spherical aberration when flipping the orientation of the collimation lens. The same process was repeated for a wedged shear plate, but only qualitatively looked at this time. As you can see, the main difference is that the zero aberration system still has linear fringes, and adding defocus and decenter looks a little bit different when done on the wedged shear plate. This process was also done to qualitatively observe the effect tilting and defocusing a mirror had while testing it with a wedged shear plate interferometer. And that concludes the lab. Thanks again for watching, and I'll see you again next week.